Hi guys, welcome again to my YouTube channel. Guys, we have a question here to solve, and I read the question first. Determine the area of the shaded region. So guys, we have a region here we need to determine. That is the area of the shaded region. Guys, as you can see, we have a smaller circle here, and then we have a big circle here. In between, guys, using this straight line that is running from this point to this point, that is using the diameter of the smaller circle. In between that and the two circles, that's where, guys, we have our shaded region. So guys, we are going to approach this question this way. I start off, that is, guys, I will try now, because as you can see, it's a bit inverted, and so guys, I will put it like that. So when it stays like that, guys, I can now see it in a better way than the way it was. And so guys, you can see this is a circle, and also here there is a circle. So guys, I'm going to divide this into two. I'm going to divide a line running through this point, and I remove this one, and at the same time I also remove this part. So guys, we are going to start with this part of the smaller circle, and this is what we have. And so guys, this is what I'm talking about. The other place, guys, we have the other side was something like this. That is what we have left out, and the shaded part for the other circle is this point. This is what is shaded. So guys, first of all, we look for this shaded area here, and for that, guys, we find the area of the circle, of the square and the circle. First, the area of the circle will give us 1600. That is 40 multiplied by 40, which is the length of the sides. And then after that, we come and find the area of the circle, and the area of circle is given by pi r squared, and guys, that comes to 1256. So guys, now we take away 1256 from 1600. When we do that, guys, we are going to be left with that, and that, and that. But remember, guys, this area is a half of the total area of these spaces. And so, guys, we are going to divide that by 2. So we get 344. Guys, we now have to divide that by 2. So when we divide by 2, guys, this is what we get. That is 172. And then, guys, we continue. So guys, 172, we keep it aside. That is for the shaded region where we can see this. This is the shaded region. Guys, we are remaining with that and that. And so let's now go to that. Guys, we have this. This is what now remains. So guys, what we are going to do, we are going to find the area of this region shaded blue. And the area of the region shaded blue is given by this equation. Guys, here is our equation, and now I can read. It says is actually r squared all over 2, open the bracket, theta. This theta is in radians minus sine theta. Guys, we only need to know what is our radius. For the radius, this is 40, and for theta, you remember that the square had sides of 40. So from here to here is 40. So it means from here to here is 40. And guys, we have the radius for the big circle is also 40, and this is also 40. And so therefore this forms what we call an equilateral triangle with the sides 40, and therefore theta is 60. And so guys, let's now look for this shaded region. This is the blue region. For the blue region, this is what we will get. So guys, this is what we have. We have the radius squared, which is 1600, divided by 2, open the bracket, 1.046. This is the radian, that is 60 degrees. You convert that to radians, it comes to 1.046. Now minus sine 60. Sine 60 is 0.8660. And all this gives us 144. Guys, now we have the area of the blue region. Now we want to find the area of the red region here so that we can combine with this other area that we found here, which was 172. Guys, what we need is that we get the area of this rectangle, as you can see. And one of the side of the rectangle is 40. So what is remaining is this x. And how do we find the x? Guys, we are going to find from this point up to the circumference, that is 40. And so we need to get the length, the height. We call it the height of that triangle. That is the height. If we can get the height, guys, we shall now be able to get this distance from here to here, which we are calling x. And that one, guys, we do it this way. So, guys, the y, which is now the height of that triangle, is given by 40 sine 60. Remember, since it's an equilateral triangle, we have 60 here, and we have the 40 hypotenuse. The opposite is what we have y. So, guys, our y comes to that. Once we get our y, we can now take away from 40. And that one now comes to 5.36. And therefore, guys, our rectangle here, the side x is supposed to be 5.36. Now we multiply by 40. So, guys, when we multiply by that 40, we get 214.4. And so, therefore, that rectangle being 214.4, we can now take away the blue region, which is 144. So 214.4 minus 144 comes to 70.4. And so therefore, guys, our red region here is supposed to be 70.4. Now, guys, we come and add up the other region we had here, which was 172. This region was 172, which of course was this region we had now calculated. And so, guys, now we are going to add those two regions, this region and this other region. So when we add that, this is what we shall get. We have 70.4 plus now 172, which we had originally. And so therefore, guys, our solution is 242.4. And therefore, guys, thank you for listening to me. Bye.